this video, I will show a few examples for applying properties of logarithms. Let's review them. The first is the product property. If we have a logarithm of a product of two factors x and y, it could be expressed as a sum of two logarithms, logarithm base a of the first factor plus logarithm base a of the second factor. If we have to find a logarithm of quotient, then we can express this logarithm or represent it as a difference of two logarithms, logarithm of the numerator minus logarithm of the denominator. The base will be the same. The power property, logarithm base a of an exponent x to the power of r will equal to the product of the exponent r times log base a of x. Using other words, we can factor out the exponent or pull out the exponent in front of the logarithm. There are two additional properties. Logarithm base a of 1 is always 0, because if you try to switch to exponential form, you'll get a to the power of 0, and it is always 1. And also, logarithm base a of a is also 1, is always 1, because if you switch to exponential form, you'll get a to the power of 1 is equal to 1. So this is a true statement. Now let's solve a few questions. The first example is to write the given expression as a single logarithm with coefficient 1. We'll assume that all variables represent positive real numbers because the logarithms are defined only for positive values of the variables. First, we have a sum of two logarithms. Is there such a property? Yes, if we have sum of two logarithms, we can expand, we can use the product property from right to left, and we can condense actually this sum of two logarithms to a single logarithm, and it will be just logarithm of a product of k and m. Now we have a difference of two logarithms. Is there such a property? Yes, the quotient property could be applied from right to left. The difference of the two logarithms can be replaced by just a single logarithm of a quotient. So we'll get log base b of km over a. And this logarithm will be the final answer because the goal was to write each expression as a single logarithm with a coefficient of 1. We can just use one word for this process. We can say condense the logarithmic expression. It means to represent it as a single logarithm with coefficient 1. Let's do the next example. We have the following logarithmic expression. The goal will be again to condense it. So there are variations, different ways to solve this problem. I'll do it in two different ways. First, we have a difference of two logarithms. So we can replace this difference with just a single logarithm of p over q. And we have again difference of two logarithms. Let's apply the quotient property one more time. The result will be logarithm of p over q divided by r. The base is the same for all logarithms. Well, we can simplify p over q divided by r, and I'll do it on the side. We can use the regular division symbol. We divide p over q by r. Or we can change the division. It's like dividing fractions. Those are rational expressions in a general case. So we have to multiply the first expression, it is p over q, by the reciprocal of the second. And the reciprocal of the second will be 1 over r. So the result will be p over qr. And we continue with the logarithm, log base b of p over qr. And this is the final answer. I'll do the solution using a different way. I'm going to factor out this -1 from the second and the third logarithm. So I will have in parentheses sum of two logarithms. this sum of two logarithms could be replaced by just a single logarithm of the product of Q and R. And now we have difference of two logarithms, so we can replace it with just a single logarithm, applying the quotient property from right to left. So I have logarithm of P over QR, and this will be the same answer. As you can see from this example, there are variations of solving questions connected to logarithms. Here is the next example. The goal will be to condense this expression to a single logarithm with coefficient 1, or to condense the expression. Well, there's a factor in front of the logarithm. Can we do something with this factor? Anything. So we can use this factor as an exponent of the variable that stays after the logarithm. So we apply the power property, but this time again from right to left. We can do the same with just positive 3. We can use it as an exponent for 1, and we get log base a of x to the power of 1/2 minus log base a of y to the power of 3. Now we have difference of two logarithms, but in the meantime we can express this rational exponent as a radical. Instead to have x to the power of 1/2, we can write square root of x. We know that x is a positive number. And now we have difference of two logarithms. We can replace this difference as a single logarithm of square root of x over y to the third. And now we have just a single logarithm with coefficient of 1. So this is the answer. Now we'll solve problems for expanding a given single logarithm. The goal will be to use the properties of logarithms to rewrite the single logarithm as a sum or difference of simple logarithmic quantities. So we have logarithm of square root. But remember, if we have square root of x, we assume that all variables are positive. We can express it as x to the power of 1/2. And in a general case, if we have nth root of x, again we assume that for even index n, x will be non-negative. But we must have it positive because x appears under the logarithm somewhere in the example. So we have x to the power of 1n for any n. And the first step will be to rewrite this logarithm. So I can have logarithm of an exponent log base m of 5x to the third over y to the fifth raised to the power of 1/2. Now we can apply the power property because we have logarithm of an exponent. So 2 1/2 could be written as a factor in front of the logarithm. And will be 1/2 log base m of 5x to the third over y to the fifth. Now we have logarithm of a quotient, so we can apply the quotient property, and we can express this single logarithm as a difference of two logarithms. But we don't have to forget that there's a factor in front of this single logarithm, so we have to open parentheses to write this difference. So get log of 5x to the third over log of y to the fifth. Now let's take a look at the first logarithm. It is logarithm of a product of 5 and x to the third. So we can apply the product property. Instead to have this logarithm, we can replace it with the sum of 2 log base m of 5 plus log base m of x to the third. And for the other logarithm, we have logarithm of an exponent, so we can apply the power property, and we can move 5 in front of the logarithm, So get minus 5 log base m of y. We see another logarithm of an exponent here, so 3 can be moved after applying the power property in front of this logarithm. And we'll have 1/2 times log base m of 5 plus 3 log base m of x minus 5 log base m of y. Are we done? No, we have to distribute 1/2. And let's do it. With 1/2 times the first logarithm plus 3 over 2 times the second minus 5 over 2 times the third. So we have an expression that is a sum or difference of single logarithmic quantities. So we have expand the given logarithm.